For lesson 5 here, we're going to look at congruence and similarity. So what is congruence? Congruence is if two figures are congruent, their corresponding angles and sides are congruent. So when we're looking at this, triangle ABC is congruent to triangle DEF. That's what that congruent symbol means, which means A is congruent to D. So those two angles are congruent to each other. B is congruent to E. C is congruent to F. And then the sides, B and C, E and F, A and B, D and E, A and C, D and F, okay? What matters is if the triangle's in the order A, B, C, the corresponding angles match up. So A matches with D, B matches with E, C matches with F, okay? So looking at this one, this example, angle J, since that has the one line there, is congruent to angle G. Angle L, that has the two lines, is congruent to angle I with the two lines. And then K, which has 3, is congruent to H, that has 3. Now with those sides, JK has the 1 tick mark. Over here, since J is congruent to G, we have to go in the order GH, not HG. KL, so K is the 3 sides to the 2 sides, the 3 sides to the 2 sides is H to I. And LJ, L is the 2 to the 1, 2 to the 1 is IG instead of GI. So just making sure you're matching up the correct angles. Versus similarity, which we already talked about in previous unit, angle, 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 which really it's just angle, angle, because if 2 of the angles are congruent, the third is also going to be congruent based on the triangle theorem of the triangle sum theorem that the angles add up to 180. So if 2 angles of triangle are congruent to 2 angles of another triangle, then the triangles are similar. So similarity, in this, we have angle A is congruent to F, and B is congruent to G, which tells us that in the order A, B, C, F, G, H are similar, and you'll see it's just that one squiggly line instead of the whole congruent statement. So similar polygons have congruent angles, and the measure of the corresponding sides are proportional. So the sides aren't all congruent, they are just proportional. Now we're going to determine whether the following triangles are similar, and if they are, we're going to write a similarity statement. So I'm going to look at this. We've got 80, we've got 42. What is that missing side? Well, 80 plus 42 is 122, and when we subtract 180 minus 122, we get 58 for that third side. Right away, that 58 doesn't match the 60, so I'm thinking it's not similar, but we can double check. 80 plus 60 is 140. What's left over for E? 40. So we don't have all of the angles the same, so no, they are not similar. Over here, a little bit tricky because it looks like it's only giving us one angle measure. The difference is, if we think about vertical angles, this angle right here is congruent to that angle right there. So it doesn't actually matter what the measure is. We know that we've got a congruent set here and a congruent set there. As long as we have 2 angles congruent, the whole entire thing has congruent angles and therefore is similar. So I'm going to write a similarity statement. It doesn't matter where I start. Let's say I start with D. So I'm going to say triangle D, and then I go to M, and then I go to B. So we went in the order D, M, B. Similar to triangle, if I started with D, I have to start with the corresponding one over here. C to M to A. Determine whether the following polygons are similar. If so, write a similarity statement. So we know that their angles are similar because they're all right angles, but we're going to look at the actual side lengths and see if they are proportional. So this side right here is 2. This side right here is 5. Corresponding side right here, is 3. Corresponding side this way, 1, 2, 3, 4, 5, 6, 7. So we're saying the ratio of 2 to 5, is that equal to the ratio of 3/7? Well, you could divide that out if you want to, but I know that 2/5 is already simplified, 3/7 is simplified, and they are not equal. So no, they are not. Okay, number 4. First, I want to look at my similar sides. I have the right angle to the 1, so this side is congruent to that side. So 3, we are comparing to 3.75. I've got the 1 angle to the 2 angles right here, 1 angle to the 2 angles right there. So we're saying, is that similar to 5 to 6.25? And the last one, 2 to the right angle, 2 to the right angle is 4/5. So this is all one triangle. That was all from this guy compared to these were all from the other one. And I'm just going to plug this into my calculator. 3 divided by 3.75, 5 divided by 6.25, 4 divided by 5. When I do that, I get 0.8 for all 3 of these, which tells me that they are proportional, so therefore it is similar. So similarity statement, triangle DEF. So I went in the order DEF is similar to triangle, start in the same order, HJK. Okay, finding the missing values. So we know that these are similar based on the angles here. This angle is congruent to this. These 3 are congruent to this 3. These 2 congruent to these 2. So I'm going to find some corresponding sides here. We know we need x, okay? So side x right there is between the 2 and the 3. So that would be congruent or proportional to this side here. Now, I can use any of the other 2 to be the other part of my proportion. So I'm starting with, I want to know what x is, and it's the corresponding side of 4.8. I can pick any other 2. So let's say I go with this 8. 8 is between the 3 and the 1, which this one right here is between the 3 and the 1, 10. So x is where we started with, so I'm going to start with the 10 compared to 8. So this is the corresponding sides, same triangles. We can solve this proportion by multiplying 4.8 times 10, which is 48, divided by 8 equals 6. Number 6, again, we're looking at what compares. We've got the one side, 2 angles here, 2 angles here, 3 angles here, 3 angles here, 4. So if we're looking at these corresponding sides, the one that we are missing is this side x right here, which is between the 3 and the 4. So this side of 26 is between the 3 and the 4. So I'm going to compare x to the 26. Now I can pick any of the other sides. If I can avoid decimals, I will. I think it's going to be unavoidable though. But let's say I use this side right here, which is 12. That's between the 2 and the 3. Right here is between the 2 and the 3. So since we started with x, I'm going to start with this one because that has x. So we're going to do the 7.5 compared to the other one, 12. So those 2 are from the same shape. Those 2 are from the same shape. Now we can solve. We're going to multiply 26 times 7.5 to get 195 divided by 12 equals 16.2. 0.25. All right, last one. We can use something called indirect measurement, which allows you to use the properties of similar polygons to find the distances or lengths that are difficult to measure directly. So for example, measuring the exact height of a mountain, a little bit hard because you can't really get down to the middle of the mountain and just measure straight up. Measuring a tall building from the outside, or a light pole, or something where you don't really have a measuring tape that's going to be able to just easily measure from the bottom to the top. We can use this indirect measurement using these proportions. So specifically, one thing we can use is look at shadows because they are proportional if you're measuring it at the same time. So a fire hydrant that is 2.5 feet high casts a 5-foot shadow. So we've got the height compared to the shadow of this fire hydrant. Then we want to know how tall is this street light if at the same time it's casting a 26-foot shadow. So we are going to set up a proportion here. I'm comparing. We want to know the height of the light pole compared to the height of the fire hydrant. And then starting with this, the 26 over 5. So we're comparing those heights to the shadows. Heights, shadows, same shape, same shape. If you had done this differently, like if you did 2.5 is to 5 from the same shape as the height is to 26, that also works. Doesn't matter because look at here, 2.5 is multiplied by 26. Look at here, 2.5 is multiplied by 26. So I'm going to multiply 2.5 times 26 to get 65. And then we divide that by 5 to get 13. And our units were feet. So in the figure at the right, triangle DBA is similar to triangle ECA. What is the distance across the lake? This one's a little bit tricky, and there are problems like this on the assessment where people tend to mess up. Because what I want you to think about is we have two triangles, but they're overlapping. So I have this triangle right here. And then our other triangle overlaps right here. We are looking for this distance, okay? So what we can compare is 40 and D, right? Those are the corresponding sides, 40 compared to D, okay? Then for the smaller triangle, it's easy to see we're given this measure right here, that length across of 320. But the most common mistake is people will just take the other number 162 and that's what they're putting here. We don't want just this portion right here. We need the whole entire side length. So we're adding 320 plus 162 to get 482 because that's the whole side of that triangle. Now we can solve this proportion. I am multiplying 40 times 482 to get 40 times 482 is 19,280. Dividing that by 320 to get 60.25, and our units are meters.